Okay, so Hardik, over to you.
Perfect. Thank you so much for that. Yes, hello everyone. My name is Haardik. I'm one of the co-founders at Learn Web3. And today we're going to talk about building on Flow as an Ethereum developer. So my main background in this space was around Ethereum. Actually, funny story, I actually used to work at Dapper before Flow was invented. Before the Flow blockchain existed, I used to work there on the Dapper wallet and some CryptoKitty stuff. But then after I left, most of my time was spent around Ethereum. At the time, all of Dapper stuff was also on Ethereum. And then Flow came back. Flow was launched later on. So this is kind of a talk where we're going to look at the differences, the contrasts, the similarities, the mental models to think about building on Flow versus building on Ethereum. Chances are most of you have some sort of Ethereum understanding, so it really helps to sort of create that shift in perspective. And I try to answer things I knew, things I wish I knew when I first started building on Flow. So yeah, so today's agenda, we're going to understand a little bit about what an NFT is. Some of it may seem obvious to you guys, but it's not obvious to everybody. So just bear with me for that part. Then we're going to look at like what is the current state of NFTs, the implementations of NFTs on Ethereum and Flow, and how they compare and contrast with each other. And then sort of giving you some next steps on how to go from this workshop to feeling very, very confident in your flow and cadence skill to the points you'll bag a prize in this hackathon. And then we'll have some Q&A. Feel free to ask Q&A like while I'm talking as well. I have the Q&A panel open on the side so I can answer during the talk as well. But yeah, so a little bit about me. My name is Haardik. As I said, I have no first name. I am a co-founder at Learn Web3, ex-NFT, somewhat right now, not as much, and education and decentralized vaccine. And so let's start by understanding what an NFT is. And just bear with me if you've already seen this explanation 100 times. But so what is an FT? FT is a fungible token, right? So something like the United States dollar bill, where $1 is the same thing as 2 50-cent coins, right? It's the exact same thing. It can be broken down into smaller units. It can be combined back to bigger units. It's all the same. It doesn't matter. And NFT is a bit different, where different sort of tokens don't mean the same thing, right? This preserved high-end Charizard Pokemon card is not the same thing as this basic Pikachu card. This is not the same thing as a stored-up high-end card, right? It's just very, very different. Even though they're all Pokemon cards, they're all still very, very different from each other. The NFT itself, technically speaking, it's some data, right? It's a certain type of data structure that at the very least contains a token ID, which uniquely identifies that NFT from that collection. And then typically it has some metadata with it. So the metadata could include things like, name, an image, or a video, some description, the websites, or royalties, things like that. And this data is anchored onto a blockchain, the Flow blockchain or the Ethereum blockchain, whatever blockchain, where the NFT then lives, right? But like this is like the abstract definition of what the data structure is. But really, the overall picture is so much more than all of this. The current state of NFTs today, it kind of exists in multiple formats, right? There's art and JPEGs, so it's kind of like fidenzas or drifter shoes, like photography or like normal art mechanisms. There are collectibles like NBA Top Shot or FIFA Collect. There are NFT-based games like Axie Infinity. There are lands in the metaverse like Decentraland and Sandbox. There's music NFTs with sound. There's reputation tokens with floats, Galaxy, Learn Web3 badges, things like that. And then there's ticketing NFT, Ticketmaster doing some stuff, and tickets, and a bunch more. This is just what I could fit on this slide. There's a bunch more categories of what NFTs look like today as well. So if we take a step back and overall look at sort of what are the different components that go into building an NFT project, right? There's some technical parts, and then there's some non-technical parts. On the technical side, there's the smart contracts you have to write, there's the wallets you have to support, there's the what sort of distribution strategy are you going to use? Is it going to be an airdrop? Is it going to be a pack? Or are you just straight up purchasing something? Then you have to build a platform or a website where people can do all of this, and you have to make decisions around what goes on chain and what goes off chain. Then on the non-technical side, we have the marketing, utility, community, creative stuff. Some of this stuff we've already covered in the education phase before my workshop. Today, we're specifically going to focus on the sort of smart contracts and wallets part of things, and more specifically comparing it to how it looks on Ethereum. So we'll start off with Ethereum implementations to have something to compare to. So on ETH, most NFTs have this, follow the EIP 721 standard, the ARC 721 implementation, which is the non-fungible token standard, right? The extremely simple example of this is this piece of code right here, where you have a contract called game item. We have contract called game item, where in the constructor, what we're doing is we're minting an NFT to ourselves, right? And that's really the only important part of this contract, where we mint an NFT to ourselves. And if you look at this mint function, what it really does is it's just these two lines which are the main part of this function, where it increases the balance of the recipient address by 1, and then it sets the owner of that token ID to the recipient address, right? So when we called the mint function, we gave it the recipient address, which is message.sender, and the amount was 1. Sorry, the token ID was 1, and we just increase the balance of message.sender by 1, and then set the owner of token ID 1 to message.sender. So this is an extremely, extremely simple NFT implementation on Ethereum. So legendary. And then there's the metadata part. So this sets the token ID, right? I mentioned that NFTs have a token ID and then some metadata. So this sets the token ID. For the metadata, on Ethereum EIP 721, there's a function called token URI, where token URI takes in a token ID and then it returns a string. Now, this string could be a link. It could be a link outside, like an off-chain link to IPFS or to an API that you run, or it could be like an entire image as well by representing it in SVG format or base64 encoding, whatever. So, for example, this function implementation could look something like this, where you have a base URI, which is example.com/tokens, and then you just attach the token ID at the end. This complicated piece of code at the bottom, this return statement, all it really does is it attaches the token ID at the end. So you end up with a URL kind of like example.com/tokens/1 or /2/3, whatever the token ID is. And then this is an API that you control, where you can serve the metadata, where you can serve the image, the name, description, stuff like that. Alternatively, you could have it on a decentralized network. You could instead serve an IPFS link over here instead of a centralized API, or you could serve an entire JSON object directly from here. And if you actually open that URL, this is a sample sort of metadata URL I brought up. And if you open that URL, it's a JSON object, which points to an image, which is another link off-chain, and it has some attributes. So it has a mouth attribute with the value of grin, it has clothes with the value of Vietnam jacket, and so on and so forth. And if you actually now open the image link, it's one of the Bored Ape NFTs. So going back to the data structure, we had the token ID, we had the metadata. The metadata was a URL. In this specific case, it was a URL to an API, to an IPFS link, where it contained the name, an image, some attributes, and so on. And the image itself was another URL out to another IPFS location where we got this, right? So this is the metadata object, and then this is where the image points to. And this is tied to the NFT through the token URI function in the Ethereum smart contract. On Flow, this process looks a little bit different, right? Up until this point, if you've had any experience with Ethereum, this might have felt somewhat obvious up until this point, but on Flow, things are a little bit different. So Flow also has a non-fungible token standard, the NFT standard, and you can find it actually, if you want to open it up, you can find it on bit.ly/NFT standard. And this NFT standard has some interesting things we'll get into. First, let's look at what a basic NFT on Flow would look like if you did it without the standard. So this is a simple, very minimal NFT contract, the equivalent of the Ethereum simple NFT contract I showed earlier, which all it does is it creates one NFT and gives it to you when the contract is deployed. So there's three things you want to note over here. There's the first line says pub resource NFT. Then there's this weird create NFT function with an arrow in the front. And then there's this thing called self.account.save with another arrow, create NFT in the front. So what is going on over here? So this is where things start differing. And this is where you need to shift your mental model a little bit to truly understand how Flow likes to do things. So let's look at resources. There are three main topics in Flow that are very, very important to understand. The first is resources. The second is capabilities. And the third is account storage. Actually, capabilities, let's say capabilities is last. So resources, account storage, and capabilities. And we need to understand the three of them to shift our mental model from thinking in terms of solidity and ease to thinking in terms of flow and cadence. So what are resources? A resource represents a collection of data and functions. Importantly, a resource is very similar to a real-world object in that it can only exist in one place at one time. So if you think about, I have this water bottle in my hand, right? You think about this water bottle in my hand. This specific water bottle can only exist in one place at one time, right? It cannot be copied. You cannot just clone it, and it cannot be just lost. Like it has to be somewhere, just one place at one time. And it has to be explicitly created, right? Somebody put in work and effort to create this water bottle. It has to be explicitly moved. I have to pick it up and move it somewhere else. And it has to be explicitly destroyed. It won't just destroy itself just by sitting on my table, right? So a resource is very similar to a real-world object where it has all these same properties. And when we think about NFTs as resources, think about it. So NFTs have some data, right? They have metadata, they have their name, description, image, and so on. They have some functions like transfer and mint and burn and whatever. NFTs can also only exist in one place at a time. So either they're with you or they're with me or they're with somebody else. It's just can only be in one place at one time. They need to be explicitly created by the contract through like a mint function or whatever. They need to be explicitly moved. You need to transfer them yourself, and they need to be explicitly destroyed if you want to do that, like burn. So with that in mind, we come to sort of the unique account model that Flow has. And Flow has this concept, and this refers back to the self.account.save line that we saw over here. So Flow has this account model where each account has a certain, three different storage paths where it can save data. So there is the sort of /storage, /public, and /private. The way to think about it is it's folders on your computer, for example, right? You have three folders on your computer, storage, private, and public. And the difference is that the /storage path contains everything on your computer. The /private path contains sort of a subset of storage where it has things that only you can access. Right? Think of it as like a password protected folder or whatever. So only you can access the things that are in private. And then there's a public path, which is another subset of storage, which has things that are accessible to everybody. Right? So that's a public folder, anybody can access it. So each account on Flow has these storage paths. Private and public are the most important. So what happened that you can now save data into your Flow's account storage, where certain data tied to your account is private and only you can access it. And then other data tied to your account is public and anybody on the Flow blockchain can access it and look at it. So when we think about the NFT standard on Flow, we have the NFT resource, and then we have a few different resources we'll come back to that are all stored within this account storage, right? So actually, to give you a concrete example, right? Imagine the NFT resource, and resources are saved into your account storage, right? So you have an NFT, it's stored into your account storage. And now there are certain things on the NFT you want to make public to the entire world, such as the name, the image, the description, right? Everybody on the Flow blockchain should be able to see what the name, image, and description is for your NFT. Then there are other things that you want to keep private for yourself, such as the transfer function. Other people on Flow shouldn't be able to transfer your NFT out from your wallet into somebody else's wallet, right? So the transfer function exists in your private storage. Now, this might get a little bit confusing. How are functions existing in storage? But we have to go back to the fact that resources are a collection of data and functions. So if the NFT is a resource, the data, the name, description, image, and the functions like transfer are all part of the same resource. And then you kind of split that resource down the middle, and you put some part of it in your public storage and some part of it in your private storage. So again, name, image, description goes in public, and the transfer function goes in private, so only you can access that. So the non-fungible token standard on Flow has a few different resources, the actual NFT resource itself. Then there's a couple of resources you as a developer need to implement, the provider resource and the receiver resource, which allow you to withdraw and deposit NFTs. And then there's a collection resource, which contains multiple NFTs of the same type. This is also a little confusing. When I first came to Flow from Ethereum, this was very confusing for me, what is meant by a collection. Because when on Ethereum, when we talk about NFT collections, typically we refer to a certain smart contract, right? When we talk about like the Bored Ape NFT collection, we're talking about the Bored Ape smart contract usually. On Flow, when we talk about an NFT collection, we're talking about an NFT collection specific to a user, not specific to a contract. So imagine if Bored Apes was deployed on Flow. So there's the whole Bored Apes contract, but then each one of us who owns a Bored Ape has their own Bored Apes collection. And your collection can include one or more Bored Ape NFTs inside of it, right? So it's kind of like multiple people in the world have a Pokemon collection, and then within their individual Pokemon collections, they have different Pokemon cards, right? So when we talk about collections on Flow, we talk about them specific to a user, not to the whole contract. So the non-fungible standard on Flow contains a collection resource that refers to a group of NFTs, one or more NFTs from that contract specific to a user, right? So if I deploy an NFT contract, I mint 10 of those NFTs. I have a collection of that NFT, which includes 10 NFTs in it. And then you may also have a collection which includes 5 NFTs in it, and somebody else may also have a collection which includes 1 NFT in it, and so on. So these are the sort of 4 resources you need to take care of and implement when you're working on an NFT project on Flow, which follows the actual standard. So as I mentioned, you can now divide these resources. You would divide your collection resource into a public half and a private half. So your collection resource now has a collection public and a collection private, where you store different things inside of each. So a public collection, like in the collection public half, typically what you would have is things like get IDs, which will let anybody see what exact NFTs do you own. Then you would also have something like the deposit function, which allows people to give you more NFTs of that type. So like deposit it into your collection. So if you go and buy a Bored Ape NFT on some marketplace, the marketplace needs to be able to deposit that NFT into your collection. So the deposit function is publicly available. And then there's this thing called borrow NFT that we will not worry about right now. And then there's other things like that are stored in private storage that are part of the collection, which includes things like the withdraw function, where only you, the owner, should be able to withdraw the NFT out from your collection and send it out to somebody else. And it also includes all the actual NFT resources itself. So a resource within it can contain other resources. So your storage, your account storage has the collection resource. That collection resource within it has other multiple NFT resources. And you as the owner of them have the sole access, the sole full access to all those NFT resources. So it's stored in the private storage. And then the public just has some sort of functions to like get their IDs, see their name, see their image, deposit more NFTs to your collection, and so on and so forth. So let's take a look at how a simple implementation would look like if we were to actually follow the NFT standard on Flow. So I'm going to open up my VS Code and let me zoom in a little bit. Let me know if you can read this well enough. Somebody just let me know in chat if this is legible. And oh, I think chat is only for panelists. Sorry about that. I hope this is legible. Okay, somebody posted on Q&A. Thank you. So let's take a look at this contract. This is the example NFT contract I wrote, which implements the non-fungible token standard. And what is happening over here? I'll collapse some of these things to give you a high-level overview. So we have the resources we talked about. We have the NFT resource and we have the collection resource. And then I added a third resource. This is not required by the standard, but I added a third resource called NFT Minter, right? So we have three resources. We have an initializer function. This is the constructor. So on Solidity, in Ethereum, we have constructors. In Flow, we have initializers. It's the same thing. We have the initializer for the contract, and we have one sort of global public function called create empty collection. And then we have some variables and some events. So let's start from the create empty collection function. What it does, it's very simple. All it does, it literally just creates a new collection resource and returns it from this function. So what you want to do, the way to think about this is I deployed an NFT contract on the network. You as a buyer want to buy some of my NFTs. To do that, you need to have a place in your storage. You need to have a folder on your computer, like in your hard drive, in your account storage, to store those NFT resources, to store the collection resource. So what happens is when you create an empty collection, it will return you a collection resource that contains nothing inside it. It's like an empty folder. It has nothing inside it, but then you can take it and you can put it in your account storage somewhere. And then in the future, when you buy NFTs from me, those NFTs have a place to go to. They have a folder to go to. They have the collection to be deposited into. So typically, the create empty collection part is done as part of the minting function. So when somebody mints an NFT from your contract, you would check if they already have a collection for this contract or not. And if they don't, you give them an empty collection to get started with and then mint the NFT for them. So this is a public function that anybody can call to just create a new empty collection within their storage. And once they have the collection, this collection implements the different resources I was talking about. So it is divided into a few different parts. There is the public part, the collection public interface, there is the provider, and there is the receiver. So the public part of it, so as I mentioned on the slides, the collection resource has all the NFT resources inside of it. Sorry, my computer is lagging. Yeah, the collection resource has all the other NFT resources inside of it, and they are stored in this mapping. So like token ID to NFT. These are all the NFT resources inside of the collection resource. When we start it off, it starts off with an empty mapping. So initially, it has no owned NFTs. And then we have functions like withdraw and deposit. These are, withdraw is a private function, right? I told you this is part of your private storage, only you can call. And then these are like public functions, the deposit function and the get IDs function. The question now is, how do I actually distinguish between them? They both look the same. It's pub fund withdraw, pub fund deposit. How do we know what goes in public storage and what goes in private storage? So that actually has to do with how do you save these things in your storage. So if we look at the initializer, in the initializer, I create a sample collection and save it to the storage of the person who deployed this contract. So like if I were to deploy this, it would save it in mine. So what happens over here, I first create an empty collection, right? And then I save this whole collection to my overall storage, which is the slash storage part, the slash storage example NFT collection. This is where I save the whole collection. And then I divide it from the storage path into a public version where I take like a subset of it. And the way I take the subset is I say self.account.link, where I link the collection resource, but extract only a few parts of it. So I extract these two parts from it, the example NFT collection public and the non-fungible token collection public. This is part of the standard, and this is my own public part of the collection resource. And then I take a subset from the collection resource and I save it in my collection public path. So this makes this subset of the collection resource available to everybody on the Flow blockchain. So as I say, if you look at the collection resource, we implement these different things in it. And if you look at my collection public interface, we implemented the deposit function, get IDs, borrow NFT, and borrow example NFT. And these four functions are now part of the public storage because I extracted that subset from the collection resource and saved it to my public path, where the public path is /public/example NFT collection. Does that make sense? I know this is a lot, and it's okay to be confused at this point. This was very confusing to me the first time I took a look at it. So if you have any questions, ask questions, I will answer them. But just to recap again, collection resource, which is a union of 4 different things. Those 4 different things, they're all stored in the /storage path first. And then the subset of it, the public subset of it, is linked to a public path. So you take a subset of the collection resource, you put it in the public path, and its mere existence in the public path makes it such that it can be looked at by anybody on the Flow blockchain. And what's in the /storage path, the other half subset of it that we didn't extract, is only accessible to you by yourself and nobody else. So the collection resource contains within it multiple NFT resources. The NFT resource here is pretty straightforward. It just has an ID, name, description, thumbnail that we just give it in the constructor when we mint a new NFT. And where the minting happens is, this is the third resource I added. This is not part of the standard, but I created it for myself. This is an admin only resource. So only I will have this resource and nobody else can have this resource. And through my resource, I have a function called mint NFT where I can mint as many NFTs I want to whoever I want. And here I create an NFT and I give it an ID, name, description, thumbnail, and deposit it into somebody's collection. So with this overall contract, the only way to mint a new NFT is to ask me to mint it for you. And to do that, the user steps here is the user looks at this contract. The user first creates an empty collection in their storage. And this is free, anybody can call this. And then you politely ask me to give you an NFT. And then if I agree, I can call the mint NFT function because this is an admin only resource only. I have access to it. And then I can create a new NFT for you and deposit it into your collection. Right? The deposit function exists on your collection resource. So you must have an empty collection before it. And then I just increase the total supply of my NFT contract. We have a question in chat that will this example code be available? Yes, this code will be available. And in fact, code even more comprehensive than this and better described than this will be available. I'll get to that in just a little bit. But if you have any questions about anything I just explained, let me know. It is confusing. It can take a little bit of time to get your head wrapped around it, especially coming from a Solidity background. But okay, it'll go back to the visuals. So we have the account storage at /storage. We have the collection resource inside the account storage. And then we extract a subset of it, the collection public, to /public. And the /public has the functions like get IDs and deposit and whatever. And then the remaining part has the withdraw function and whatever that only you have access to. But what about metadata? In everything I just showed, I didn't talk about metadata. Flow also has a metadata standard, and this is separate from the NFT standard that they have. So Flow tries to be generic in terms of what metadata means for an NFT. And there are different types of metadata called views. So there are display metadata, such as an image or a video. There are external URLs like a website. There is some collection metadata, such as the name of the overall collection and such. There is the collection display metadata, which is, again, the description and stuff. There are certain traits, is like what clothes are the NFT wearing, or what type of mouth it has, and such that. And then there's some royalty metadata, which enforces royalty settings for the creator. These different metadata, so I'll give you an example of one of the simplest ones, the display metadata. And the display metadata is just has name, description, and thumbnail. And the way we implement it is we have to implement this thing called a resolver. And the resolver basically returns a list of what different views does your NFT contract have. I listed like 6 different views over here. The resolver has 2 functions: get views, which tells you all the different views that you have, and then a resolve view function, which gives you specific details about that view. So you could have a get views function that tells you, okay, my NFT has a display view. And then when you resolve that view, it returns the name, description, and thumbnail for that NFT. And you can mix and match. You can have multiple views per NFT. You can have any sort of permutation combination of these different views. Typically, the most common ones you'd like to use are like display, collection data, collection display, probably, where you can define name, description, and stuff for the overall collection and for the individual NFTs. But then occasionally you might also need traits, external URLs, royalties, depending on what you're building. That was a lot. So I want to start comparing and contrasting the different languages, the different ecosystems, what the wallet scene looks like, and really understanding where the NFT actually lives, which is probably the biggest advantage of Flow over Ethereum. So when we talk about Solidity versus Cadence, Cadence is the language you use to create contracts on Flow, as you just saw. So there's a few things that are different. So first of all, with Solidity, I'll go through pros and cons, right? So Solidity pros it's been around longer. There's more resources around it, and typically there's a lot of different ways you can find help for it. The cons of Solidity are it's very easy to make mistakes in Solidity. Every week, every day, we see as like, oh, $100 million hack, $500 million hack, whatever. Things keep happening in Solidity, and that's because to truly write good Solidity, you need to really understand it. You need to really understand the inner workings of the language. There are a bit too many gotchas and a bit too many, what did I do? That make it really hard to write good Solidity. The thing with Cadence is, it's a newer language, not as many resources around it, and it's really only used for Flow smart contract development at the moment. The pros, however, is I understand I just said a lot of things, and it was probably confusing to understand resources and storage and capabilities and whatnot. But all of this combined, once you get it, Cadence makes it very, very hard for you to write wrong code. Right? Cadence makes it very hard for you to write incorrect code, such that, especially with the resources and not being able to move it or not being able to you need to explicitly do everything you want with resources, and nothing is just like a hidden under the hood feature that happens. Cadence makes it very hard to write wrong code, which over time can help your contract stay more secure. So that is, I think, one of the biggest pros and cons differences between the two. Obviously, it has some catching up to do in terms of how many resources are available to help you out, but it makes it very hard to write wrong code once you get the hang of it. Then, secondly, the wallet ecosystem. The Ethereum wallet ecosystem, there's more options, self-custody, fully custodial, middlemans in between, and whatever. There's a ton of different options, but typically as a developer, if you have to support multiple wallets in your application, it's also very common in Ethereum to have to write specialized code for each wallet you have to support, or for each category of wallet you have to support. Like browser wallets are treated differently than mobile wallets, are treated differently than hardware wallets. And you as a developer need to spend time writing supporting code for all those different wallet ecosystems. On Flow, generally there's the standardization around wallets. So no matter which wallet you're using, Dapper, Genie's, Ledger, Block2, whatever, they all are standardized to fit in with the Flow client library. So it's just a single client-side library where you can, connect to wallets, make transactions, get the state of the blockchain, do whatever you want, all from a single library. And if in the future new wallets are created for Flow, they will be compliant with the FCL library. So you don't need to do anything special as a dApp developer. So it saves some time over there. And then you have all these different options, especially with walletless onboarding now, where you don't need to manage your private keys and everything on Flow. The most important difference, however, I really want you to think about this, is really think about what account storage really means. The fact that these resources are stored in your account storage is a bigger deal than you might think. And why is that? Because think about it this way. On Ethereum, we saw that when an NFT is minted, all it really does is it increases somebody's balance and marks the owner of that token ID to a given address, right? And this information is stored within the smart contract. This is information that is part of the state, the contract storage. On Flow, as we saw, these NFT resources, they're stored directly within account storage. They're stored directly with the user, not the contract. The contract has nothing to do with the NFT resource after it has been minted, and it is part of the account storage. You do whatever you want with it. The difference, what this leads to is, in case of a security vulnerability, imagine your contract had some bug that allowed a malicious hacker to come in. On Solidity, if they were able to gain access to your contract, that also means they have access to your contract state. And what this means is, if I hack the Bored Ape contract somehow, I can do whatever I want with all of the Bored Ape NFTs, with whatever I can change their images, I can change their metadata, I can change the owners, whatever I want to do, because it's all part of the contract state. And the owners of that NFT can do nothing about it. On Flow, this isn't really possible, because even if I was to hack your Flow contract, the actual NFTs that have been minted are no longer stored in the contract. Those NFTs are stored with you, the users. So I can't do anything to your NFTs when I don't have access to them. I only have access to the public parts of them, which I can't do anything with. And the private parts of them, you have it in your account storage, and I can't do anything about it. Right? So this is actually a bigger deal than you might realize. It's sort of a security feature where the storage of it between the contract versus the account helps you write more secure code over time. That was mostly it for me today, but I want to talk about next steps. This was meant as a workshop, try to help build that mental model for you. What I want you to do next, if you're taking part in this hackathon, if you're serious about taking part in this hackathon, on Learn Web3, we have a full flow course, a full-length flow course available for you. I am biased. I would say it's the best flow course in existence you will find today. And it covers everything from basic cadence to building in the playground to setting up the Flow CLI, having a local developer environment, all the way to building an app using like React and Next.js with a full project. More specifically, if you go through the course, you will build 3 different projects on Flow. One, which is a simple to-do list. The second, which is a domain name service. So kind of like the find domains or ENS domains on Ethereum, you'll build your own domain name service. And then in the third one, you will build an NFT marketplace. So all of these are free. This entire course is free. You self-paced, take your time, do whatever you want. If anything, I would recommend one section of that course. If you're stuck on time, there's not a whole lot of time. If you're stuck on time, I would recommend at least go through level 6, 7, and 8 of this course, which is the domain name service. Level 6, 7, and 8 are probably the most comprehensive Flow documentation and resource you will find on how to build contracts on Flow. I highly recommend going through that. The link to this is, I don't think I can actually post in chat because chat is only for the panelists, but let me type an answer in Q&A. So you want to just go to learnweb3.io/courses and just create an account over there. And you should be able to see this in the Q&A section of Zoom. Just go to learnweb3.io/courses and you have the Flow course. But if you're pressed on time, do level 6, 7, and 8. If you have time, do the whole thing. But that's the next steps I would say for you, which will take you from what I just told you about the mental model and the shift from Ethereum to actually building really complicated smart contract mechanisms on Flow. It's everything from a to-do list to an NFT marketplace, as I said, right? You'll understand the NFT standard, you'll understand the fungible token standard, you'll understand how to take payments in Flow tokens to mint NFTs, you'll understand a bunch of different things, how to connect it to a front end, how to build a full dApp. All of that is part of the course. Yeah, go check it out, learnweb3.io. You can hit us up. If you have any questions, message me on Discord, message me on Twitter. It's all at discord.gg/learnweb3 and at learnweb3 DAO. That's all for me today. If you have any questions, I'll stick around to answer. But yeah, that Flow course was actually created in partnership with the Flow team. So it's up to date. If you find something, if you have any doubts in there, I'll be there to answer your questions even after this workshop. And yeah, that's all from me. And thank you so much to everybody for attending.
Yep. Thanks, Haardik, for the amazing session. And yeah, let's see if anyone has any questions.
Actually, I got a question in the beginning I didn't pick up about dance NFTs. I actually have no idea what that means. I don't know what dance NFTs are, but yeah, thanks to everybody saying thanks to me. I don't know. This will be I look forward to seeing what is built in the Flow Hackathon. Flow's been getting some great news recently, and yeah, I want you to succeed.